Hi everyone, this is the video lesson for Pascal's triangle and binomial theorem, day 2, part 2. If you haven't watched day 2, part 1 yet, please go back and watch that before continuing with this last part of the 4-part video. Now, so far, if you go back to day 1, part 1, all the way to the current video, we've talked about Pascal's triangle, we've talked about a couple of ideas behind this triangle. We even went on and expanded a couple of binomials to some power n using Pascal's triangle. And we even showed how you can use Pascal's triangle to find a number of pathways from A to B. But the one thing we never got to, which I can finally share with you, is the actual binomial theorem. So again, in grade 12 data management, you will learn this for sure. And at this point, I'm just going to introduce it as follows. So the binomial theorem is given by the formula a plus b to the power of n, which equals to, and again, you can put this in expanded form, you can put it as a summation. I'm going to show you both. So this is the sigma notation, and you're basically taking the sum of n choose r of a to the power of n minus r times b to the power of r, and the counter starts with r equal to 0 all the way to n. And what this really means is if you expand this, the first term is going to be n choose 0 times a to the power of n minus 0 times b to the power of 0. So again, what we're really doing is we're looking at the number 0, and you're counting it from 0, 1, 2, 3, all the way to n. If n is 5, then you go from 0, 1, 2, 3, 4, and you stop at 5. If n is a billion, then you go from 0 all the way to a billion. And anyways, if you keep going, I'll show you just maybe a couple more terms. This will be n choose 1 times a to the power of n minus 1 times b to the power of 1. And the pattern continues until you get to the very last term, which really is b to the n. And the reason why it's b to the n is because the first term, if you look at it, this is really a to the n. And again, we're going to circle back to the idea of combinations, which I talked about from day 1, part 1. If you haven't watched it yet, go back and just reactivate those skills. And choose 0, that's going to be 1. And we know that, and there's two reasons for this. One is because and choose 0, which is in the world of combinations, means there are n objects in front of you. How many ways can you choose nothing? And the answer is 1. There's one way to choose nothing. And of course, a to the n minus 1 is a to the n, and this last part, b to the 0, anything to the 0, in this case, that's going to be 1, just like that. Now, I'm going to apply this. So, I'm going to go back to something very simple before we do something a little bit more intense, and we're going to use both methods. We're going to use Pascal's triangle, we're going to use binomial theorem, and we should be getting the same final answer. So, x plus 2 to the power of 6. Let's find a brand new page. I'm going to do this with you. Let's separate this into two different columns, and we should be expecting the same final answer. If we get a different answer, that means something is incorrect in our line of thought. So again, let's just call the first column the binomial theorem. And of course, in the second column, we can say using Pascal's triangle. And you should be comfortable with both methods. So, here we go. The example was x plus 2 to the power of 6. So, x plus 2 to the power of 6. X plus 2 to the power of 6. Okay. So again, before we start with the first column, one more time, just to reactivate this. By definition, the binomial theorem is going to be a plus b to the power of n, which equals to the sum of n, choose r, times a to the power of n minus r, times b to the r. You're starting with the lower index of 0 with the upper index of n, just like that. So, let's show you, and I'm just going to copy this again underneath so you can see every step. So, x plus 2 to the power of 6. So if we follow this formula, this equals to the sum of n, which is 6 in this case, choose r, times a, which is x to the power of n minus r, which is 6 minus r, times b, which is 2 in this case, to the power of r. Again, r starts from the lower index of 0 all the way to the maximum of n, which is 6 in this case. Now, let's kind of draw an arrow. We need lots of space. So again, all we're doing is this. You're counting from 0 all the way to 6. You're counting from 0 all the way to 6. So this is going to give you 6, choose 0, times x to the power of 6 minus 0, times 2 to the power of 0, plus, remember, sigma means you're taking the summation of, you're adding a bunch of terms. 6, choose 1, times x to the power of 6 minus 1, times 2 to the power of 1, plus 6, choose 2, times x to the power of 6 minus 2, times 2 to the power of 2, plus, we're almost halfway, 6, choose 3, times x to the power of 6 minus 3, times 2 to the power of 3, plus 6, choose 4, times x to the power of 6 minus 4, times 2 to the power of 4, plus 6, choose 5, times x to the power of 6 minus 5, times 2 to the 5, plus the final term, 6, choose 6, times x to the power of 6 minus 6, times 2 to the power of 6. Now, again, you can take the calculator, you can do it using the formula. Again, if you want to use the calculator, make sure you're using the combination key. So just double check if you have a scientific calculator, like an actual scientific calculator, you're going to find this and choose R key, and that's how you can find 6, choose 0. Now, of course, another way, right, before I even show you that, is we knew this, right, from the triangle. The numbers would have been 1, 6, 15, 20, 15, 6, and 1 respectively. So if you just kind of use that, that works too. But anyways, if you take the calculator, 6 choose 1 is going to give you 6, times x to the 6, 2 to the 0 is going to be 1, plus 6 times x to the power of 5, times 2, maybe I'll put this in brackets, we're going to clean this up a little bit in a moment, plus 6, choose 2. I'll pick up my calculator just to show you that you can also use that. You don't have to do it using the triangle. 6, choose 2 is going to give you 15, as expected, times x to the power of 4, times 2 to the power of 2, which is going to be 4. Again, you can put brackets around this if you like. Plus, let's try again, plus 6, choose 3. That's going to give you 20, times x to the power of 3, times 8. Again, I'll put brackets. Plus 6, choose 4, which is 15 now, times x squared, times 16, because 2 times 2 times 2 times 2 is 16, plus 6, because that's 6, choose 5, times x to the 1, times 6 to the times 2 to the power of 5, which is 32, plus 6, choose 6 is 1, times x to the power of 0, times 2 to the 6, which is 64 actually, not 32. Let's write this again. And now here comes the final answer. Let's clean this up. So the final answer should be x to the power of 6 plus 12 x to the 5 plus 60 times x to the 4 plus 160 times x cubed plus 15 times 16, which is 240, times x squared plus 6 times 32, that's 192, plus 64, oops, there's an x that I forgot to write. Now, if we're doing this right, in the second case, we should get the same final answer. Let's find out. Now, this we did in the last video, so if you haven't watched it yet, go back and just reactivate that. But you have to copy this 7 times. So the fact that the exponent is going to be 6, you copy it 1 more than the exponent, so 7 times. Now, once you copy this 7 times, the second step is to look at the exponent and you're counting down. So you start with 6, 5, 4, 3, 2, 1, and 0. You go backwards, 6, 5, 4, 3, 2, 1. And if you're doing it right, you'll always end up with the 0. Again, you look at Pascal's triangle, that's going to be 1, 6, 15, 20, 15, 6, and 1. The fact that there's a plus sign, you're going to add them. And again, this is something that we already did. So I'm just kind of going through it with you just to confirm. If I clean this up, this is going to be x to the power of 6 plus 2 times 6 is going to be 12 times x to the 5 plus 15 times 4, that's going to be 60 times x to the 4 plus 20 times 8, that's going to be 160 times x to the power of 3 plus 15 times 16, which is 240 times x squared plus 6 times 32, because 2 to the power of 5 is 32, that's going to be 192 times x plus 2 to the power of 6, which is 64. The moment of truth. Did we do it right? Let's find out. I don't know. So far, both x to the 6, 12x to the 5, 60x to the 4, 160x cubed, 240x squared, 192x plus 64. They are the same. And all kidding aside, we should not be surprised. We're just really doing the same problem using two different methods that both work equally well. So comment below. I would love to find out which method you gravitate to and why. And again, we're all wired differently, so there's no right or wrong answer. I'm just curious in terms of who likes which method more. Now, if I go back to the handout, this is something that you should try on your own. We talked about this already. We've definitely talked about this. This I want to talk about a little bit more, but the rest of this you should be able to do on your own. So just to recap, the idea of factorial, combination, and you can go from there. So factorial and factorial, by definition, is going to be n times n minus 1 times n minus 2 times n minus 3 all the way to 3, 2, 1. And it's important to understand the meaning, not so much just the math, because I know you have a calculator and you can always input output, so that's not the most important part. The most important part is the meaning. So n factorial is actually the formula that you can use to find out the number of ways to arrange n distinct items. So maybe I'll end it like this. If you have one item, or two items, or three items, and this is now not combinations, but it's more permutation where order matters. Again, I'm just going to give you an intro, and then we'll end it there. If there's one object, right, there's one way to rearrange this, which is 1. So you can think of it as one book on a bookshelf. There's one way to rearrange that. If you have two books, let's call them A and B, you can rearrange it on your shelf, either in the order of AB or BA. And really, the shortcut is you take 2 factorial, which is 2. So 2 ways. If you have 3 distinct objects, let's say 3 different books on a bookshelf, you can arrange them in the order of ABC, ACB, BAC, BCA, C, AB, CBA. And I'm just counting it, right? And of course, the shortcut is 3 factorial, which by definition is going to be 3 times 2 times 1. So the answer is going to be 6 ways. Now, let me over-deliver. This is a hard question, and if you understand this one, we're finishing strong. If you take the calculator, I know that you can find out the fact that 0 factorial equals to 1. But the question is why? And most students can find out the answer, but not every student understands why. Now, comment below, and I will tell you if your answer is right. Why is 0 factorial equal to 1? I hope this makes sense.